So I'm going to start with the example that's in the book for a Lewis acid base that goes beyond something that you've seen before with the boron trifluoride and ammonia. And a Lewis acid, remember, is an electron acceptor. Electron acceptor. And a base electron donor. Electron donor. So what's going on up here? We have boron with 1, 2, 3 fluorides and ammonia. Now boron doesn't have any free electrons, but ammonia does. So ammonia with its 3 hydrogens is actually, the base. It is going to donate its electrons to boron. And that's what forms up our final complex here. And so there's a few things that the book doesn't really hit on. And first of all, it might bother you that boron is violating the octet rule here. We just kind of throw that out there and don't even talk about it. But remember, boron only has 3 valence electrons. 1, 2, 3. So it can actually violate the octet rule because it's going to pair electrons with somebody else. So in this case, it's pairing with a fluorine electron here and here. So it is stable. It is not a charged species, but it does have room to accept those couple of electrons that the ammonia has to give. So it is indeed the acid, and this is the base. Cool. Now, hopefully, a question that comes to mind is an acid increases or decreases pH, rather. So a lower pH is an acid. And a higher pH is a base. Well, how is BF3 going to increase a pH concentration, especially as we're going to talk about in the next section? The pH is based on concentration of hydrogen, or actually the hydronium atom. So if that's the case, how is BF3 doing that? Well, let's look at what BF3 does in solution. So we have BF3 plus H2O. And what is this going to go to? Probably not obvious right off the bat. You'd have to do some playing around with this to see it. We get HBF4 plus H3BO3. So when we put it in water, we do actually get this guy, which is our acid. So this one is what increases the pH, or decreases the pH, increases the the hydrogen ion concentration. So this is what creates our acidic environment in water. So in this particular case, we're not talking about whether we're in water or some other sort of solution. We're only looking at what happens with these electrons and can this species accept it. So remember, a Lewis acid accepts electrons and a Lewis base donates them. So to figure that out, what you want to do is start drawing Lewis structures for everything, and that will make the picture much clearer as to who our acid and base is.